Did you guys see that countdown?
No, I
Okay.
didn't see one.
Okay. Okay. Well, welcome to Chemistry 100. Um, we can probably look at Moodle a little bit before we get started talking about content stuff. But hopefully you have looked at this a little bit before this meeting, but if not, not a big deal. I'm serious about these first three rules. If you click on everything in this Moodle page, then you'll learn a lot more than and about when things are due and what it is that you need to do to get stuff done. And when you do that, depending on what the situation is, these boxes on the right hand side will get checked off. Sometimes you just need to look at something and it'll get checked off. Sometimes it won't check it off for you until you have an actual grade submitted. For the forums, it won't check it off until you like post and then reply to somebody else. So there's lots of reasons why these things will or will not check. But by the end of the course, you should have all of these boxes checked off. When the first thing you should do when we get out of this is go over the syllabus probably again because we're gonna go over it here in a second. But that's where all of the like sort of like a contract between you and me, how many points everything is worth, and if there's a problem, you can always point to the syllabus and says the syllabus says this, and so this is the way it's got to be, and that is the way it's got to be. This obviously you guys found the Zoom guide or the web meeting. I'll record these and then I'll put those recordings right down here. And if you miss the class and you want to watch it later on, I would suggest taking notes and then writing questions down, and you can post it in this forum right here, and then either me or another student can answer those questions for you. This is the course content guide about the things that we're going to be going over in this class. A lot of it have to do obviously with chemistry and then human involvement as far as what chemistry has done to humans and the planet in general. Here's some pictures. I'll throw some chemistry style pictures in there. There's some videos for YouTube here, some interesting science stuff. If you have student help desk things, you can click on this. All the Moodle sites pages have this thing, but I'm actually the Moodle administrator for the entire college. And if at least two of you have found out, if you have a problem with Moodle, you can message me and I will fix that problem or have somebody fix it for you. This alternate formats video, can you guys see this download option thing here that I'm pointing to?
Yep.
So if you click on that, you can click on alternative formats. And so if I've got a Word doc up and you don't have Word, then you can download it as a PDF or you can download it as an audio file, which might sound ridiculous, but it actually works. It just sounds a little, robotic and whatnot. You can download it as an HTML, or maybe you want EPUB and you can read it on your Kindle. So these are all these different options you can download this stuff as. Let's see what else we got. There's a little bio about me. I've been here since 2002. This is actually the first time I've ever taught this class online, though. I've definitely taught it several times live. But with everybody having crazy schedules, and I was the probably the most shocked person when the college called me and said there's 47 people trying to get into this class, and I'd say 3/4 of you said it was because it was available with your schedule being online and asynchronous. So this is mostly asynchronous, which means you can log in at any time and handle everything. The only thing that's not asynchronous is this. But again, this can be because you can watch the recording, but it's not really interactive if you're watching the recording. Okay, so a major component of this class, I say this right here, is this Reading for Understanding guide. So you have these chapters out of the text, and I'm listing how many pages each of those are. Following this guide is going to be key to you doing well in this class. This is probably something almost none of you have done before. Most of us read in a way that is easy for yourself. This makes it a little harder, but it allows you to retain information a lot better. So there's many aspects to it. Scanning through it, reading all the bold print, reading the section headlines, looking at all the graphs. So when you're filling this thing out and you're submitting this, and again, this is a major portion of your grade, this won't be a small document. This will be fairly lengthy, several pages. I've had people submit these and they're 12 pages, and that's a little overkill. But the point is, you're reading every single word out of the textbook, and you're basically spitting out back to me what you think that means. And then I can read that and say, oh, you read that paragraph and you didn't, the author wasn't very clear. And so what you thought that author meant isn't exactly what that author meant. And so I can make sure that your understanding is crystal clear. So the first one, I'm guessing many of you are going to make mistakes on, and that's totally fine. But we'll get that corrected, and then everybody will be on the same page with what I expect for these reading guides. Again, here's where the Zoom meetings are going to be published. The recordings are, and again, if you have questions, even if you're live to the meeting or not, go into this forum here and post the questions, and then somebody in here is going to, either me or somebody else will be able to answer that question for you. We only have one quiz, so you can hit that quiz up anytime you want. It most likely, well, you've got until Sunday. It won't take you very long. It's not very hard. I don't know, maybe a half an hour. If you spend a little bit more time on it, that's fine. Yeah, you have to type basically a 100-word paragraph describing something. So when you go into that, you'll see what I mean. You're gonna have a paper that's gonna be due week 10, and this paper everybody's gonna have a different topic. So I wasn't expecting there to be 47 people in this class, so this might be a little harder than I thought. So maybe there might be some topic overlapping because, again, I wasn't expecting this many people. So you're going to pick something about chemistry and how it's impacted humanity. Can somebody give me an example of something about the subject of chemistry that has impacted human culture, human society? Anything?
Atomic bomb?
All right. That's kind of chemistry. There's definitely some chemistry involved with it. It's probably more nuclear physics or nuclear chemistry, but there was a boatload of chemistry that went into making a nuclear bomb. So sure, we've got the ability to destroy ourselves many, many times over. Where in the news right now, why is this a problem?
North Korea?
North Korea. So North Korea has made a bomb. North Korea has been historically, since we invaded them and made them very mad at us, they've been historically upset with us, and our president hasn't done himself any favors. We thought it was okay. It turns out it's not. But yeah, they actually have a rocket that could hit Oregon, California, Washington, and Alaska. So it means a little bit more to us than it means to, say, somebody in New York. So if they got irritated enough at us, they could lob a small nuclear bomb over at us, and the rocket's only semi-accurate, so if they're trying for Portland, they might hit Hood River. So yeah, that's a pretty big impact. How about something good that chemistry has done for humans?
Plastic is one thing, because we use plastic in pretty much everyday life.
Yeah, I'm gonna go with good and bad on plastic.
Yeah.
The plastic is amazing. I mean, think about, just look around your space. What is made out of plastic? How about look around your space and what's not made out of plastic? That's sort of where we are. The problem with the plastic is we're really, really, really bad at recycling it. And what did China do last year that made it more difficult?
Stopped accepting new recycling materials.
Yep, all that recycling material that wasn't paper or glass was being shipped off to China, and they would segregate it and they would recycle it. And they said, Americans, you have dirty recycling. You do not rinse out your containers that are made of plastic. They would get containers that had like Thousand Island salad dressing in it that were half full. That messes the entire process up. It might not seem like a big deal, but an entire batch of recycled plastic could be ruined because somebody didn't rinse out their Thousand Island salad dressing container. So that happened, and so now we're kind of stuck with the aftermath of you guys are throwing all of your recycling, and where's it going? Does anybody know? It's actually going to the landfill.
Landfill.
Yeah, they're dumping it in with the regular trash now. They don't want you to stop recycling, putting it into the recycling bins, because they don't want to mess up your habit. So hopefully we can find somebody else, or somebody else in this country will start accepting the plastic to be recycled. But until that happens, we're trying to keep everybody still recycling, in that habit of recycling, because we don't want it to be like another big deal to try to get people to recycle again. Did anybody read anything about a couple of whales that have washed up dead on shores in California and Italy associated with plastic?
Oh yeah, their whole bellies are full of it, right?
22 kilograms in the one in Italy, and 25 kilograms in the one in California. The one in Italy was pregnant, couldn't give birth because it died because its bowels were stuffed with plastic. Because does anybody know what a plastic shopping bag looks like to a whale?
Krill.
Not krill. Food. Anybody know what food it looks like? Think about what a plastic shopping bag might look like floating in the ocean.
Jellyfish.
Looks like a jellyfish. That's food.
Jellyfish.
Yeah. So they're like, yeah, food, and then they eat it. Tastes weird, no big deal, and then obviously it doesn't make it through their digestive tract because they cannot metabolize that plastic. So pick something, post it in the forum here associated with the paper. You're going to write a basically it's about 2 pages, 1,200 words, plus or minus 50 words, 12 font. New Courier. So I'm being really specific about this because I want you to follow the instructions perfectly. So make sure you read through this and do everything that it says here. If you have any questions about it, don't hesitate to ask me or post a question on the forum, and maybe somebody else can get to it before I do. And then you can submit it with a PDF or a Word doc or Google Doc. And don't forget that it has to, the citations that you use have to be MLA format. And if you don't know what that means, Google it or send me a message and we'll talk about it. Hopefully it's something that you got from one of your writing classes. Okay, so end of chapter questions. So if you click into this week 1 here, what I want you to do is find a question in the back of chapter 1 and post that question. And so the discussion topic that you put in will be the actual question number. And then somebody else is going to answer that question. And then you're going to answer somebody else's question. So then we should have, I don't know, close to 50 questions up there, which is over half the questions in the back of chapter 1. And then we'll have 50 plus responses. So every week, each of the chapters that we're dealing with.
You have a specified time that we need to have our question posted?
Yeah, when you click into the individual chapters, it actually tells you when those are due. I don't know why it's not showing for me, but it shows it for you. Let me show you what I see. So it's April 1st to April 7th. So that's this first week to get that first one done. And then the other way that you can know when these things are due is if you go down to the calendar down here that is refreshing. Anything that's highlighted blue or has that orange background, I'm sorry, this probably looks weird to you. Is that better? I like everything to have a black background. So anyway, so orange and blue. If you hover over this, it will tell you that quiz 1 opens this day. And then if you hover over another day, so something else is happening here, you can click on that day and it'll tell you the events that are happening. So then exam 1 opens on the 10th and lab 1 is due on the 10th. So you'll know when these things are due. So like on the 7th, there's a whole bunch of stuff. That's not right. Oh, I didn't change the settings for 3, 4, and 5. I will change that today, right as soon as we get off of here. So on the 7th, you should have the discussion board stuff posted. So this little icon right here that looks like 2 little talking bubbles, that means a forum. So if I hover over this, it's saying that the week 1 forum should be completed. So that's the question, ask a question, answer a question. You should also be done with quiz 1. or sorry, you should also be done with the quiz. And you should have clicked on something that says alternative formats, which is this guy right here. And so to get this little box checked like I have it, you have to click on this, and there's like a 45-second video to watch on it. So anything that's highlighted blue with the orange background is telling you something either started that day or ends that day. Does that answer your question, Christine?
Yes, it does. Thank you.
Yeah, okay. So again, this click on everything, read it, try to get all those boxes checked, and then that calendar thing over there is going to be super helpful to you. So you can just log on and immediately forget about looking for stuff that's due. You can just start highlighting, putting the cursor over stuff to figure out when things are due and when things start. Because you don't have access to everything. Like you can't see these labs down here because I don't want you to start on them yet because they're not relevant to what we're talking about quite yet. Let's see what else. Okay, so watch this lab safety video. It's not the worst thing that's ever been made, but it's probably not far away from it, but it's very informative. I mean, they tried to be a little funny with it, I think, at least I hope so. It's 35 minutes long, and it's about things not to do in lab. And since lab is your kitchen or your garage or something, it's going to be very important that you follow those instructions. And I've tried to pick labs that are as chemistry related as possible that won't make your house burn down. So don't burn your house down. The last thing are these exams. So we have 8 chapters that we're going to go through. So every exam is going to be 2 chapters. So the first exam is will open up on, I think, the 10th, and then you'll have a week or so to take it. Maybe it's 2 weeks, and then it'll be, well, let me just click on it. I think it says, I can't remember. All right, so there's 40 questions. They're multiple choice, true and false, and matching. They'll be from the lecture and content from chapters 1 and 2. There's only 1 attempt allowed for it. The exam has 40 minutes, will last 40 minutes. So a minute per question, and it'll submit it as soon as the 40 minutes is up. So just be prepared, and I guess the thing I'd say the most is make sure nobody's going to come in and interrupt you for 5 or 10 minutes, because that might mess everything up for you. And it's not currently available. It's available on April 10th, and then it'll be available till April 24th, and so you can take it during that 2-week period. So each of the exams are going to be the same thing. They'll be over 2 chapters. There'll be multiple choice, true and false, and matching. Yeah, okay. There isn't going to be any math in this class. The other chemistry class I teach, the series 121, 122, and 123 is a lot of math. The 200 level series is tons of math. And what I found is the people who do poorly in that class are trying to learn how to remember how to do algebra and stuff at the same time they're learning chemistry. So all we're going to do in this class is conceptual stuff about chemistry. There won't be any reason for you to even have a calculator. I'm pretty sure it's not even in the syllabus. Let's look at the syllabus. Are you guys seeing the syllabus now? No?
Not yet.
Wait, no or yes?
No.
Okay.
I just see the middle page.
All right. Let me... How about now?
There we go.
Yeah. All right, good. Okay, so there's my name, there's the course, online, 4 credits. I have tutoring in Hood River during these times and on those days. And then if you have any other questions, we can always throw together one of these little meetings and you can ask me questions. A lot of times people they just need like 3 minutes to ask me some questions. And so I've done that with my regular classes, especially last term when we had a ridiculous number of snow days. The chemistry, the textbook that we're going to use is this Chemistry in Context. So those ISBNs, the 10-digit one and the 13-digit one, I mean, I found it for $2 online. I don't know what they're selling it for in the bookstore, but if you just go to like half.com or thrift books or something like that, you could have got it very, very cheap. Definitely need a periodic table and that laboratory kit. So this class is going to talk about topics pertaining to everyday life. It's going to we're going to talk about renewable energy and clean air and water and global climate change. It's a, again, non-math approach. We'll talk about the basics of chemistry, including atoms and molecules, the table, bonding, intermolecular forces, which is one of the most important things that nobody knows about, and chemical reactions, acid base, and then the social environmental roles of chemistry. So you'll fulfill some of those requirements with that paper. The things that we're going to need to get out of this class are effective communication. So if I don't understand what it is that you've written down, that's not going to be super helpful to anybody. The problem-solving thing is going to be incredibly important for us because that's lacking in American culture these days. I'd say half the population just reads something and believes it, and they don't care that what they read is completely irresponsible from a person with an agenda. We'll talk about how to determine if what you're looking at is important or is just kind of made up stuff. There'll be a lot of cultural different stuff that we talk about as far as the United States goes, mostly against the rest of the world. And then the consequences of what we've been doing for the last 150 years on ourselves and the natural world. So I'll expect you guys to log into Moodle several times a week. And then if you can make the meetings, not super important, but would be helpful because then you get to ask questions real time. If you turn something in late, your grade will be reduced a point per day. And then if you've got something that's going on in your life, just let me know. That whatever it is going to be more important. Like somebody was supposed to be here this week, his grandfather passed away and he had to travel out of the country to go to the funeral and be with his family. That's way more important in this class. So if something like that happens to you, just let me know and we'll work it out.
How often are we going to have the live Zoom meetings?
I'm going to do it twice a week at this time on Mondays and Wednesdays.
Okay.
There isn't any extra credit. Just do the credit. So we'll have grades from forum postings, from the notes from the reading that you guys take, quizzes and labs, and everything's weighted in the normal way you would expect. An A is 90, a B is in the 80s kind of thing. The quiz is worth 20 points. There's just the one quiz. The forum postings, 10 points per week, 100 points for the class. The reading notes, 40 points per chapter. There's 8 chapters, so that's 320 points. So that's obviously a significant portion of your grade. It's the largest, actually. There's going to be quizzes, exams. I should change that. Sorry. I should say exam. And so 40 points a piece, and so that'll be 160 total. Every single point in this class is weighted equally. So if you miss a point on a forum, that's exactly the same thing as you missing 1 point on a lab or 1 point on an exam. So every point counts. And then you've got the 8 labs that we're going to do, so that'll be 160 points total. And then each of these labs and the exams and all of this, their due dates are all in Moodle. They're all hopefully very clear, and if they're not, you definitely let me know.
What time will the Zoom meetings be?
6, same time every day on Mondays and Wednesdays.
Thank you.
Yep. These are just things that all the syllabi have in them about don't cheat, and the ADA policy, no discrimination. I can't imagine that there's going to be an issue with the flexibility of the course, but I suppose maybe there will be a time when I can't meet on a Monday or Wednesday because of personal reasons or something going on with the college. So if that happens, then that's a possibility, but it's slim chance of that. So we We also have alternative assignment statement if there's an issue with that, inclusiveness, and if there's a problem with student services or support or anything, you can get a hold of them there. The woman you want to talk to is Shane et al. So if anybody has a disability or anything like that, contact Shayna. She'll contact me, and then we'll work it all out. Does anybody have any syllabus questions? Okay, take that as a no. I'll stop sharing that. Kill that. Save. And go back over here. Okay. Did anybody start looking at the textbook? No,
Yes.
a little bit.
No, Mickey, you're
I didn't assign chapter 0, but chapter 0 is kind of important, just as like a jumping off point. But it's not something that that you need to read. But since we're here, I'm going to talk about a couple of things out of chapter 0, and one of them is something called shifting baselines. Has anybody here heard that term before?
No.
Anybody?
No.
No. Okay. So what shifting baselines is what we think about the world around us as sort of a default. So do you expect everyone to have a cell phone?
Yes.
Do you think that was the case when I was in college?
Oh no.
It absolutely wasn't. I knew nobody with a cell phone. They were not a thing. You guys have probably seen funny pictures of the cell phones from that time. Does anybody know what those things were called?
Bricks.
Bricks. Why? Because they're the size and weight of a brick. So obviously nobody's going to be carrying those things around. So the shifting baseline for cell phones is you expect everybody to carry a cell phone around with them. That's a shifting baseline. So how do you think that applies? Can somebody give me any instance that they can think of where a baseline is shifted over the last 10 or 20 years? For anything.
Social media.
More people.
Social media. Did anybody have a Facebook account 20 years ago? A MySpace account? Those things didn't exist. Twitter didn't exist. Nobody would expect anybody to be able to share photographs of their children with their family members, all of them at the same time, instantaneously. That's just not something anybody expected to be able to do. And now, obviously, somebody has a baby, you totally and fully expect to see pictures of that baby online within, I don't know, 5 hours of that baby being born. Sorry, was it Shane? Were you going to say something?
Online meetings like this?
Sure, yeah, online meetings. How many, do you have any idea what the apparatus would cost to do this 10 years ago, what we're doing right now? When we were looking at it 8 years ago, they were $10,000 units. So we had one in Hood River, and we had one in, that was actually like 8 years ago, one in the Dalles campus. And all we could do is talk back and forth between those two campuses. I certainly couldn't go into, like, I saw somebody had like a moose or a deer in the background of their house. There's no way. I've seen a couple of people's dogs. This is definitely not something that could have happened even 8 years ago. So this is definitely a shifting baseline. Did you have something to say, Shane?
For shifting baselines for me, I'm a gamer. I hate the new like battle royale. What like everyone's into playing. I hate this with a passion.
Could you imagine when, say, Super Mario was a thing that you could play other people online live?
Me, I was born in '88, so I was like, been playing games for years and years and years. And online hasn't become, a real aspect in gaming until like the mid 2000s.
Yeah, I remember when Xbox Live came out and we got it the first day, and you had to jerry rig everything to get it to actually work. And that was the first instance of it. And now there's probably more games you can play with other people than games you play solo. Maybe that's not really true, but feels like it. Okay.
Or even TV has changed drastically. Of course, I'm telling my age now, but it has changed tremendously. I mean, you can hook your computer to it. You can control it with your cell phone. You know, of course, I wasn't raised with a TV, but I know that it has changed tremendously.
Yeah, I remember we had channel 2, channel 6, channel 8, channel 10, channel 12, and then every once in a while you could get channel 49. And that was it. And that was it for a decade until cable came out. And now you're right. I mean, you can watch DirecTV on your phone, any place you want. And now when you click on something and it doesn't load in your phone in like 1 second, 3 seconds, you get a little irritated about it. Everybody knows who Bill Murray is, the comedian Bill Murray. If you don't,
Yes.
you should watch anything he's done. Bill Murray. I guess most recently you could watch Zombieland. Actually, that's not that recent, maybe 3 or 4 years ago. But anyway, he said something about knowing somebody's underlying attitudes. Give them a computer with slow internet speed for 15 minutes and see how they act. And that will tell you what kind of person they are. We don't expect to have slow internet speeds. When it's slow for you, there's probably like a dramatic problem because we're expecting everything to happen very, very quickly. So something more important as far as shifting baselines go, how many women are running for president? How many women ran for president 25 years ago? I remember in 1988 election when Geraldine Ferraro was the first woman candidate vice president that went into election. I mean, they lost, but that was amazing that there was a woman who was actually up for vice president. And so now we've got half dozen, maybe more, at least 2 strong contenders. And obviously we had a really strong contender in the last election, just didn't quite work out. But what we see happening around us in the world changes based off of what happens to us every year. Does anybody know how many days in Hood River County we went without rain last year? 86. Does that seem like Oregon? Does Oregon seem like a state you're going to have 86 days of over 70 degrees and no rain? No, it was horrible. Mount Hood didn't look like Mount Hood. It looked like some mountain that didn't have snow on it. Mount Adams looks even worse. So for us getting hit with that snow this February and March, that was a huge deal. I had already received letters. We have a small farm, and I had already received letters from our ag water distributor that we were going to have to conserve before they even started giving us any water. They didn't turn it on March 15th like they're supposed to because they were so worried about it. So they're trying to hold off as long as possible before they start allowing the reservoirs to be used up. Because what would happen if we didn't have agricultural water in Hood River Valley? How many farms are here?
A lot.
How many people come here to help with farming? A lot. The Hood River County would basically cease to exist as we know it if we didn't have agricultural water. Plus, what would happen to the price of apples? What would happen to the price of pears? It would skyrocket. It would be astronomical. I don't know if anybody knows this, but do you guys know what happened in the Midwest the last 3 weeks? Anybody?
Sinkholes.
Say again?
Sinkholes?
Flooding?
Flooding. There were sinkholes because of the flooding.
But didn't they have some, wasn't there a river that completely changed its course?
Yeah, a town disappeared. The whole
Right.
town, just gone. It was on a turn and it's gone. Why? Because we're affecting global climate with what we've been doing to it for the last 125 years.
Groundwater reservoirs, right?
Yeah, we're I'm talking about this now because I just asked about what happened to the price of apples. Did anybody hear what happened to calves? Baby cows?
Yes, it was horrible. It was the fact that, well, it was talking about, the article I read was about this river that changed course, and the hay was completely ruined. He lost half of his, cows, and basically he said he was going to get out of farming.
Absolutely. The issue, the article that I just read that came out from the U.S. Ag Department was that just in Kansas, 750,000 calves drowned. Just Kansas. So what's going to happen when those cows were supposed to be slaughtered? They're not going to be there. So just like the price, this price of beef is going to go through the frigging roof. I'm not joking. It's not going to be a little bit. It's going to be like $10+ a pound, because the bulk of the cattle are in the Midwest and they drowned. So we're talking like 2 years from now, the price is going to skyrocket, but it'll probably end up happening sooner because everyone's going to freak out and start buying as much as they possibly can and storing it in freezers. So be aware of that. That stuff's going to like disappear. Okay, so shifting baselines again. We're more accepting of the fact that we're having these hurricanes that are Katrina-like every year. That Katrina hurricane was something nobody'd seen before. And now we're seeing Katrina-like hurricanes once or twice a year. That is a shifting baseline. And we need to realize that the things that are happening around us that seem normal are incredibly weird. So what this book is going to try to impart on you, and what I will as well, is the fact that we're hosing the planet. And the planet doesn't care. When everyone says, when you get people saying that save the earth is going to be fine. The earth is here and it's not going anywhere, but we might all go somewhere. So how do we stop ourselves from killing ourselves? Well, the first thing is you need to understand the problem. And a lot of people don't want to understand the problem. A lot of people just want to bury their head in the sand and keep going the way it is. Why do a lot of people who have a lot of money want to do that?
They don't want to waste it on that specific thing. It might not be important to them.
There's been a pretty funny video floating around about people voting and rich people voting. They always vote. They know exactly who they're going to vote for, and a lot of it has to do with they're not going to be here when all this happens. So why do they care? The real issue is people with lots of money using media to convince people that don't have a lot of money that we shouldn't worry about this kind of thing. When actuality, it's the most serious thing that's happening to us. The most threatening thing to us is killing ourselves by changing the environment of the planet. And it might seem like it's far away, but it's just around the corner. Has anybody seen the new Green Deal that was discussed in the House of Representatives 2 weeks ago?
It's just a delaying tactic.
I disagree with you, couldn't disagree with you more. There is no delaying tactic by removing fossil fuels from the equation, and that is the issue. The issue is we need to stop burning fossil fuels, period. And that seems, if we think about where the fossil fuels are used in our economy, it seems impossible. But it can't be impossible. It simply can't be impossible, because if it is impossible, then we're not going to survive. The 7 billion people that are on the planet, there aren't going to be 7 billion of us here in the next 100 years. We're going to drop off like dead flies, because that's what's going to happen. When all of those calves died in the Midwest, does anybody else know what else happened when all of those calves died? Besides the fact that all the beef is gone, what else was destroyed?
Land.
The land that grows most of the wheat and corn, all of that was annihilated. That they need to come in and refertilize all of that. It's not going to be an easy feat. So it's not just calf prices, beef prices that are going to go up. It's going to be it's going to be all food prices. So everything that you buy to eat is going to be more expensive. What do you know what the United States exports?
Corn.
Well, the number one thing we
Majority of our
export,
goods are made of corn.
Yeah.
Everything.
the number one thing we export is food, and the number one food we export is corn, followed by wheat. We make so much corn, the rest of the world basically lives off of, they get all of their corn from us. And we destroyed about those floods destroyed about a third of the acreage where the corn is being grown. So that needs to be drained, dried off enough for us to start planting as soon as possible. But we're basically going to lose at least a half a season of corn growth. And when we provide food for a good portion of the planet, that's going to be a problem for the planet. Not for the planet, but for the humans on the planet. The Green New Deal seems on the surface to be very extreme, but it's only because people are ignoring the extreme nature of what's happening to us. So what we're going to do in this class is we're going to go through and we're going to talk about many things that humans have done using chemistry to manipulate the environment. Most of those things are for the bad, and what we can do to stop that. If anybody in this class wants to have an argument or a discussion with me about the fact that the climate change isn't happening, we can absolutely do that, either as a class or individually. But there is no source that you can give me that's a legitimate source. There isn't one. So when Fox News says, well, we have these scientific sources, those scientific sources have all been debunked. The one guy from an Ivy League school, we found out that he has accepted $1.9 million from an oil lobbyist. So a bunch of oil companies gave this lobbyist a bunch of money, and then they gave him money, and then he trumped up a study, and that study said that it's not that bad, when in actuality it is. There are no legitimate sources of information to say that we're not doing what it is that we're doing. Let's see, I've got this picture. Is it right here? Graph. Do I want this one? Let me share this thing over here. Share this. Share. Huh. Doesn't look like it's in here. All right, I'll just Google it. Why can't I get that thing? There we go. All right, so you guys, can you see this graph?
Yep.
So if you look at the y-axis here, this is telling you the carbon dioxide concentration in parts per million, and then these are the years. So this is an observatory in Hawaii. Why is Hawaii a good place to check air concentrations of different substances in the air?
Because it's still remote, they don't have giant processing factories near it.
Yeah, they're out in the middle of nowhere. This is actually on the west side of the island. So there isn't anything upwind of it except an ocean. So by the time the air gets to the observatory, it's basically the entire northern hemisphere's air that's been mixed together. So it's a very good, everyone's accepted the fact that this is a nice average for the entire planet. So what we started doing was measuring the concentrations of carbon dioxide in the 50s. And first off, what's the deal with this up, down thing? So every year the concentration seems to spike and then drop and then spike and then drop.
The cold months and the warm months.
Okay, so winter and summer, right? What happens during winter? Most of the trees lose their
Winter.
leaves, right? So
Yeah, it degrades and then
when the plants stop doing what they're supposed to be doing, which is photosynthesis during the winter, the carbon dioxide levels spike. So all those little spike ups, those are all during the winter because the plants aren't pulling carbon dioxide out of the atmosphere because they went dormant for the winter. And then during the summer months, they're out there doing their thing, breathing in carbon dioxide and drinking water and producing oxygen and sugar. And that happens during the summer months, so the CO2 concentration goes down. But those plants haven't been able to keep up with the carbon dioxide concentration. So what we're seeing, we've almost increased it. Can you guys figure out about how much this has gone up? It's close to 100 ppm, but about what percentage is that?
About a third.
About a third. We have about a third more carbon dioxide in the atmosphere than we did in the 50s. Why is that a problem? What is
Because
it?
we're not meant to breathe carbon dioxide.
Well, that's not carbon dioxide. Those concentrations of carbon dioxide aren't going to affect our ability to breathe. Anybody else? I heard a couple other people talking.
Doesn't carbon dioxide hold in heat better? Like it allows Earth to heat up quicker, easier. We did an experiment in geology where like two tubes, one with air, one with carbon dioxide. The one with carbon dioxide heated up way quicker than the other one.
Absolutely. Breed's got that, nailed that. So if you have a room and that room is, let's say, I don't know, a greenhouse. So you've got a glass building and that building is filled with carbon dioxide. The light that goes into that building doesn't leave that building as easily as if it was filled with just air or even oxygen. So what carbon dioxide has the ability to do is keep energy in. So why is that a problem? We're going to find out in chapter 1 and in chapter 2 is the sun provides 99% of the energy on the planet. The sun, we don't absorb all of the energy that comes in. What do you think happens to a lot of the energy that hits Earth from the sun?
it's
It's reflected off of it. Absolutely. How do you know that? Because we had a spaceship in space and you could see the Earth. We also can see the moon. And so the light is hitting the moon and then reflecting back down to us. So these celestial bodies will reflect radiation. So the light comes in and hits us, and actually most of it bounces off of us. But what's the temp on the moon?
Isn't it like even 60 degrees on the light, like minus 88 at night?
Yeah, so it's cold. I mean, we're talking very, very cold. On the dark side, we're looking at near absolute zero temperatures, and on the light side, when it's being hit, we're talking warmer, but we're talking like 100 degrees Kelvin, which is negative hundreds of degrees Fahrenheit. Why is the moon so cold and Earth is not so cold?
lack of a thick atmosphere.
Yeah. So we got a blanket around us made of mostly nitrogen and oxygen. And then we've got some other gases in the atmosphere, like carbon dioxide and water vapor and a little bit of argon. But for the most part, 99% of our atmosphere is composed of nitrogen, which is about 80%, and oxygen, which is about 20%. That last 1% is these other trace gases. The issue is carbon dioxide does a much better job of keeping, it's a much better blanket. If you wanted to blanket something and keep it warm, keep the radiation from reflecting off, then you'd coat it in carbon dioxide. So what happens is the radiation hits the planet and then it's reflected off of, say, like the windshield on your car. And if it's going up, if it hits a carbon dioxide molecule, the carbon dioxide absorbs that energy. and now that carbon dioxide is warmer. So instead of that ray of sunlight that was supposed to leave, it got absorbed by the carbon dioxide. And the carbon dioxide just keeps doing this and keeps getting warmer and warmer and warmer, basically holding in more heat than we're supposed to have. So what would happen if, say, 5% of the heat that was supposed to leave didn't leave? The planet gets 5% hotter. Is that a problem? Yeah,
Yeah, huge problem.
that's a huge problem. How come you're not worried about getting a bacterial infection or a viral infection from your dog?
Because the human body's too hot and it kills it.
Other way around.
Oh,
The dog is about 4 to 5 degrees warmer than you are. And the bacteria and viruses and fungus, the microscopic organisms that can live and hurt your dog, infect your dog, can't live 5 degrees cooler in your body. How come you can't get your dog sick? We've had the flu for like 10 days, the flu and or cold. I mean, this has been like the absolute worst spring break we've ever had. My dogs are definitely, we have 6 dogs. None of them are sick. Why? Because their body temperature is 4 to 5 degrees above ours. And so, I mean, I could sneeze right into one of their faces and it wouldn't matter because that body temperature is higher. 4 to 5 degrees is plenty of, the entire environment of what can live in that changes. Most of the things that live on the planet are microscopic organisms, and so if the microscopic organisms have a problem, we have a problem. It's a chain, right? We're all in this together. All these organisms are in it together. What would be horrible if many microscopic organisms died? Does anybody know where most of the oxygen comes from?
algae?
Algae, microscopic organisms. Microscopic algae that are plants breathe in CO2, get water from the ocean, and then they spit out the oxygen that we breathe. So what happens if those microscopic organisms die because the ocean got 2 degrees warmer? We die. We start to suffocate. This isn't something to sneeze at. This isn't a little thing. This is a huge thing. So that number right there on the far right hand side of 400, we're past that. This is an old graph. We're in 2019. We've passed that green line, which was the line that we said we needed to not pass. Because passing that line means we have a very short time period to bring the temperature back down before we irrevocably change the entire ecology of the planet. And again, Earth doesn't care, but the things living on Earth are going to care. So what we're going to find out in this book and talk about in this class is the things that we need to do as humans to not let this happen. And I guess I have a huge problem with the other side of this saying that it's not an issue. I don't understand why anybody has a problem with us coming up with an entire new industry. Do you think it would be bad if all of a sudden we needed to employ 100,000 people to make solar panels and 100,000 people to install solar panels? Does that sound like a bad thing for the country? No. Does it sound like a bad thing that we need to retool every car company to produce cars that are like Teslas or like Nissan Leafs or vehicles that run on all electric? Does that sound like a bad thing?
Only people that really have a problem are people that have built their fortunes on old money and relied on all these old sources like oil and whatnot.
I totally agree with you, Shane. What those people should do is be smart and immediately convert everything over into green technology. Start giant companies that make batteries, or start a car company that makes electric cars. Who am I talking about?
Oh, I think I know somebody like that.
Maybe just one guy that's like that.
Yeah, just one African American guy. Yeah.
Yeah. Okay. So I know Elon Musk is a little crazy, but he's crazy in a mostly good way, and he's not going to be hurting for money. the things that he's doing are forward thinking and not backward thinking. And so that's what we need to be doing. There's no reason why we can't move forward with this. There are so many different things that humans can do to fix the problems that we've made, and then all of this stuff will be better. Like everything will be better. Think about, I mean, were you guys spending a lot of time outside towards the end of last summer? What was going on in the gorge?
Nice big old heat wave.
Anything else?
Fire.
Fire. How many of you were outside during those 3 weeks? It ruined my summer of mountain biking. I mountain bike in Post Canyon, and Post Canyon was hit hard, so you can't ride in that. What you're going to find in this chapter, this first chapter about air, is something called PM2.5s, which are particles that are in the air that cause problems with breathing. Basically, we're just talking about smoke, and the smoke has different levels of size, and those can do different things to you. When we have issues like this, people, like the ER, will have a whole flood of people that have emphysema or other problems with breathing. They have to come in and have pure oxygen put on them because their lungs are irritated by the particulate that's in the air, and that particulate causes inflammation, and then their airways collapse on them, and they literally can't breathe. The holes are not big enough for the air to get through. And that was happening last summer. The amount of particulate in the air was causing people to not be outside because of the amount of irritation that it was causing lungs. You'll find that California was the first state to enforce a lot of these rules, and it's not perfectly clean, but it's thousands of times better, the air in California, than it was before they started that. When you're going through this first chapter, you'll be talking about substances and how we classify substances. So do you guys know what the difference between a pure substance and a mixture is? Can somebody give me an example of let's start with an easy one, a mixture. Any kind of mixture.
Salt water.
There you go, salt water, perfect. So you know it's two different things because you can separate them out. You can boil the water off, and then you're left with salt, and then you know you had water because it was there. So a mixture is just something that you can separate out without using any chemistry. And a pure substance is something unto itself. So after you've boiled that salt water out of the water, that thing left at the bottom of the pot, that's a pure substance. That pure substance is, in that case, probably table salt. The pure substance that came off, the water, I mean, you could capture that on the top of a lid for that pot, and all of a sudden you had gaseous water turn into liquid water. So you'll see the textbook talking about different types of matter. So they come in the mixture type, or they come in the pure substance type. The mixtures, they come in two forms. If I gave you a glass of salt water, would you know it by looking at it? No.
Maybe?
Okay. It's completely clear and colorless. As long as you didn't put so much salt in it that some of it wasn't dissolved. If you just sprinkled a couple of sprinkles of salt into it, you'd have no idea. So that is a mixture, but what we're going to call that a homogeneous mixture. What does that prefix homo mean? Same. So it's a mixture that looks the same all the way through it. So a homogeneous mixture, you can't tell that thing's a mixture. Can you give me an example of something that looks the same all the way through it, but is a mixture? How about, have you heard that homogeneous word before? Let me say it a different way. Homogeneous.
Oh, like milk.
Milk. There you go. 2% homogeneous milk. So that just means that the milk looks the same all the way through. Has anybody seen milk that hasn't been homogenized? If you're interested in that, Next time you're in Rose Hours, go over to the Huckleberry section where the milk is, and on the top shelf, there's some milk that's not been homogenized. Does anybody know what that looks like? It looks like there's some water on the bottom of the container and some cheese on top of the container. And you have to shake the heck out of it to get it to look a little bit like milk. And then if you wait, it'll separate out like oil and vinegar, like Italian salad dressing. So homogeneous is a mixture that is a mixture, but it doesn't look like a mixture, like butterscotch pudding. So we have lots of other mixtures, and most of those mixtures don't look the same. Pizza, obviously, there's a lot of things there, and it doesn't look the same when I'm looking at the top of the pizza, the top and bottom all over. There's pepperoni and sauce and crust and cheese and whatnot, so it doesn't look the same. So do you know what the opposite of the prefix homo is?
Hetero.
Think about it with like sexual orientation.
Hetero.
Nobody? Hetero? Right? So a heterogeneous mixture is a mixture that doesn't look the same all the way through it. So we could say tapioca pudding. It's got those little balls of tapioca in it, right? So it doesn't look like butterscotch pudding because those little things are in there. Pizza would look like something that's definitely heterogeneous. Okay, so if I'm looking at matter, I can say it's either a mixture or a pure substance. And so we just talked about the mixtures. So let's talk about pure substances. A pure substance is anything that is an element or a molecule. So let me pull up a periodic table. Did everybody find a nice periodic table? That's part of the thing that you're going to need. You're going to want a periodic table like when you take the quiz. Sorry, take the exam. Like right there on your desk with you. Topics.
Got one of them.
All right, let me share this. Share. There we go. Okay, so here's periodic table of elements. This each of these substances would be considered a pure substance. They are literally just by themselves. If I put them together in a chemical bond, then I'm going to have a molecule, which will also be a pure substance. Does anybody, are any of you interacting with any of these things that are up here that are pure substances? I mean, most of the things that are around you are mixtures or well, they're mostly mixtures. But is there anything up here that's a pure substance that you guys know of that you might have around?
Iron.
Pencil lead, graphite.
Sure. Okay. That word lead is super misleading because pencils used to have actually lead inside of them, but now it's just graphite. So literally, it's just carbon. Another way to get carbon all by itself is just like charcoal briquettes. So if you want to make a campfire or you want to do a barbecue, you can just put straight carbon in there. You're actually breathing in N2s, right? Nitrogens and oxygens. So those guys are in their elemental form. So somebody said iron. There's probably actually not a lot of iron floating around. Does anybody know why pure iron isn't something that people usually use? It rusts too easily.
Because it's super heavy.
So instead of just having pure iron, they'll mix it with other metals and other substances like carbon and make steel, and then it becomes less corrosive, or it corrodes less easily. but most of these things you don't come across in their elemental form. Number 24 here, chromium. So if you've got a bumper that's got chrome on it, or even like a pencil, sometimes a pencil has like a really metallic-y coating on some of the plastic, like a mechanical pencil, or the on a pen. Sometimes the little thing that clips it to your pocket, those are coated in pure chrome. How about copper, silver, and gold?
Oh, like wedding ring?
Your wedding ring is probably going to be a mixture of gold and another substance. There's almost zero chance you've got some gold around that's pure, unless you've got like a commemorative coin or something like that, because most of the time the gold is just too soft to wear as jewelry. The same thing goes for the silver. It's usually mixed with something, but you definitely have some copper laying around. Where's the
Wiring?
wiring? Yeah, it's all over the house in wiring. Anybody can think of something more tangible that they can like put their hands on?
Penny.
A penny. So the exterior of any penny made after 1982 has copper on it. The interior of that penny is made out of zinc. Any penny made between World War II and 1982, those are pure copper, 100% copper coins. The funny thing about it is, does anybody know how much a penny is worth? Because it's not 1 cent.
5 cents?
It's the last time I checked, which was earlier this year, was almost 3 cents. Like the fact that you had a penny is about 3 grams, and 3 grams of copper is worth almost 3 cents. So why are we still making pennies? I don't know. And it is illegal to melt down pennies into copper, but honestly, nobody would know it if you were doing it. And for every penny you melted down, you could get almost 3 cents for it. But again, it has to be a penny made before 1982 or the beginning of 1982. So if the penny weighs 3 grams, that penny is a pure copper penny. If it weighs 2.5, then most of it's zinc, and it's not worth nearly as much. Okay, so these guys are all pure substances because they're elements. And then the other type of pure substance that we've got would be molecules. So can somebody give me any molecule? Anything at all?
Like hydrogen?
I can't completely disagree with you because hydrogen's found as H2, but it's still just hydrogen. So how about if I say a binary molecule, a molecule made of more than one element?
Oh, water. Or H2O?
Sure, water's the easiest one. So, second. So, share that. That's what a water molecule looks like. And a water molecule is a pure substance. It's got 2 hydrogens and 1 oxygen. It is actually oriented in that angle. It's super important that it's like that. It makes water phenomenally weird. And we will talk about the fact that water is ridiculously weird. And its weirdness is literally allowed life to be on this planet because it is a weird, weird substance. But the reason that this, even though it's composed of 2 different types of atoms, is a pure substance is 2 water molecules are exactly alike. And I can't separate water molecules into their oxygen and hydrogen without doing some chemistry. So the main difference between a mixture and a pure substance is in a mixture, I can separate those things with physical characteristics. Like I could have a bucket of sand and somebody could sit there with some tweezers and separate the sand out into its components. You can't do that with a water molecule. I can't hit this with an axe or a hammer or something and get the oxygens and hydrogens to separate out from each other. That is a substance unto itself. If I ran electricity through it, I could actually get the water and oxygen to separate out, but then I had to do chemistry to it. So if I'm only doing physical stuff and I can't get the thing to separate out, then what I'm looking at is a pure substance? How about something besides water? Nothing? How about there we go. Gasoline is a pure substance, not the gasoline that you buy at the gas station, but what you're hoping to buy. This is the molecule that you want. It's got 8 carbons and 18 hydrogens, and they're oriented like this. There's 5 carbons in a row, and then on this carbon right here, there's going to be 2 carbons, 1 on each side, and then on the second to end, I'm going to have another carbon. This molecule right here, we call it isooctane. If you go to the gas station and you look at the pump, and it will tell you what percentage of the gasoline is this molecule right here. So if you you can buy different grades of gasoline, the higher grade will give you more of this. If you went to a drag race or something like that, then those guys would be using gasoline that was 100% this molecule right here, because this molecule is the best molecule to run through your car. The other molecules, not necessarily great for it, but your car puts up with that. Yeah, see, this guy, wherever this image is from, this is not correct, because this is not actually the molecule that's in gasoline. This would be a terrible molecule for gasoline or for diesel. That's actually pretty good for motor oil, and that would be decent for plastic. But need a little bit more with that. How about this pure substance? Do you guys like this pure substance? Thiobromine?
Yeah.
What is it? My guess is all of you would say yes if you knew what it was. The active ingredient in chocolate. The thing that makes chocolate chocolate. So I've seen this on t-shirts a lot. Well, not a lot, but as far as molecules on t-shirts go, it's usually this one or ethanol, maybe some other molecules that are more or less fun, but this one gets used a lot. That one and the caffeine molecule, I guess, are both are up there a lot. Let's look that one up. Did I spell that right? Nope, did not. Dang it. I'm trying to get these to be on the same screen. Can you see both those molecules? No? Just the one? All right, let me try this.
Just the one.
All right. Share new. Share snipping tool. Share. How about now?
Yeah.
Anything look familiar between those two molecules?
The nitrogen and the oxygen.
But for the most part, the molecules are exactly the same, right? Except for the upper left-hand corner. There's with caffeine, there's a nitrogen here, and then this is called a methyl group, a carbon with 3 hydrogens, and over here it's just a hydrogen. So do you think chocolate, thiobromine, and caffeine are similar molecules? Yeah. If somebody eats a whole bunch of chocolate, do they get stimulated? Yep. Why? Because it behaves very similar to the way caffeine does. So when somebody has a mocha and it's got chocolate and caffeine in it, they should be very stimulated. All right. Okay. Let's talk about one more thing. Um, sorry, I'm trying to Google a reaction, but it's not popping up easy. I'll just type it. New blank. Let's make this huge. And then I go share and share and share. All right, so then we've got H2 plus O subscript 2 X H subscript O. Okay, do you guys know what this chemical reaction is?
Making water.
Okay, so you're making water, but what is so we've got hydrogen gas here and we've got oxygen gas here. So what happens when I put these two things together? What is it? Anybody have any know any properties about hydrogen gas?
Combust.
Okay, absolutely. That's what you're looking at. You're looking at the combustion of hydrogen gas. So to combust something, you're burning it, and to burn something, you need oxygen. So if I take oxygen and I put it together with hydrogen and I give it a little push, I'm going to make water molecules. So this is a reason that I love chemistry. This thing is flammable, right? This is what you need to make anything burn. Together, they make the thing that puts fires out. What happens when I run electricity through this stuff? Does anybody know? Do orientation landscape. I get the oxygen and hydrogen back. So this is combustion of hydrogen gas giving me water. And then I could take that same water and go back and turn it back into hydrogen and oxygen. So how do your cars run? What process makes them drive around?
Combustion.
So wouldn't it be nice if I could put this thing in your car? Wouldn't it be nice if the combustion, the thing that was being burned, was this thing? Because then what comes out of your tailpipe?
Just water.
Just water. And then what could you do with water? Well, if I had electricity, I could get it to separate into hydrogen and oxygen. And then I could put that back into my gas tank. Does that seem like a good idea?
Yeah, but it's not convenient for the oil industry.
It's definitely not going to be good for the oil industry. I totally agree. Where could we get the electricity to get the water molecules to separate into hydrogen and oxygen?
From the generation of the combustion in the first place.
Maybe, but every time you do a step, you lose some energy. So
yeah, you lose some energy.
It's not going to work out for you in the end. How about the giant nuclear reaction happening in the sky?
Solar power.
Yeah. So we could use the sun to separate water molecules into hydrogen and oxygen and burn those and get the water back. Then we could take that water and separate it into hydrogen and oxygen and burn it and get that water back. And we wouldn't have to worry about messing the planet's atmosphere up. That would just require us to make lots and lots of solar panels. Or what else could we make lots and lots of? That we make lots of around here. That generates electricity for us.
Windmills.
Windmills, right? Wind turbines. So as soon as you get past, get out towards Biggs, you get around towards John Day River, you you see all those wind turbines? How many of you have been in Sherman County at night?
Yep.
What's it look like in Sherman County at night?
Lots of red dots on the horizon.
Yeah, it kind of freaks me out. I always feel like War of the Worlds is happening. Like all the aliens in the universe are invading Sherman County at the same time because there's just all that red glowingness happening. Those wind turbines could all be using all of their electricity to separate hydrogen or water into hydrogen and oxygen, and then we could use that hydrogen to put it into your car tank. So there's lots of things we can do. Your car wouldn't run off of hydrogen gas right now, but it could be modified to run off of hydrogen gas. So we don't even need to make all the cars electric. We just need to change the internal combustion motor a little bit. We already have 2 internal combustion motors readily available, diesel and gasoline. So we could easily start making a third. It would be very easy for us to do this. But again, as somebody, I don't know if it was Shane or Reed said, the oil industry isn't going to be too happy about that. They don't want to see that happen. So right now we got a lot of rich people stopping us from doing what we should be doing. Why does it make sense that we should do something like this? There are like 2 really good reasons besides the climate change thing. Somebody give me a really good reason why changing the fuel source we use for vehicles would be a good idea.
Well,
A lot more affordable for younger people.
I in the first place.
All right, let's go Reed, go for it, and then we'll go Shane.
It's a lot more affordable for regular people if everything ran on water.
Sure, yeah, absolutely. It would eventually be incredibly cheap. You could actually do this at your house, right? If you had a sufficient number of solar panels, you could buy the system. And there is a guy in near White Salmon that I know does this. He actually has the system and the solar panels, and he separates out the hydrogen from water and generates hydrogen gas, and he runs his house and his vehicles on it. So this could be, all of us could do this, and we would be completely independent. We would never have to go to a gas station. That's kind of problematic for somebody like Shell or BP or Texaco or Exxon, right? They don't want to see that happen. Shane, what was your reasoning?
It's like water. It's essentially everywhere. It's one of our highest supplying elements out there. Because we have oceans of it.
We've got lots of it, right? What's happening to the amount of fossil fuel on the planet? It's a finite resource. We are going to run out of it. So why wouldn't we start switching over to something before we actually run out of it? I mean, that's the thing I don't understand about people saying that we can't do this. We're going to have to do it at some point because there's only so much fossil fuel on the planet. There were only so many dead dinosaurs and dead forests from dinosaur times that have been turned into oil. So we're going to have to do this. Okay. So what I'm going to wrap this up here. My daughter has decided to join me. Say hi. Say hello. No? Okay. So what I want you guys to focus on, and let me stop sharing this and go back over to Moodle. Where is it? There it is. Share. There we go. Is getting these boxes checked off. I want you guys to start working on these. Maybe post your why. Like watch this alternative formats video, download the syllabus, read over that, and then most importantly, download this guide, read the entire thing, and start working on this. Start reading through that first chapter and following the guidelines for this reading for understanding. And that way, if you do it now, then you can ask me questions before it's actually due. Don't forget to post questions. Again, these things are due it on Sunday, I believe, the forum questions. And you have your lab due this week. So that's all I got for you. I will end this and and post post the recordings on the website. So thanks for showing up. We'll talk to you guys later. Bye.
Thank you.
Yay.
Mommy!
That wasn't mommy, you crazy girl.
Or Daddy, Mom.